Good morning, everybody. My name is Kouassi Konan Jean-Claude, and I am a PhD student in artificial intelligence at the Faculty of Computer Science via distance learning at Bircham International University, BIU of Madrid in Spain. So BIU is a top 10 world-ranking distance learning university and one of the best alternatives to campus-based higher education. It is also a member of the most prominent organizations ensuring distance learning education quality in the world, such as the ASEAN Association of Open Universities, the European Association for Distance Learning, and the United States Distance Learning Association. I'm also a senior computer scientist at the Ivorian Civil Service, currently in service at the Ministry of Environment and Sustainable Development in Côte d'Ivoire. So I am here for presenting my paper, a comprehensive overview of artificial intelligence that has been accepted by the conference. Content at a glance will pass first to the abstract and go through the 8 parts of my paper. So why is a comprehensive overview of artificial intelligence important? First, you know that breakthrough in the field of AI, suggesting its similarity with human beings and multiplicity of elements, success and senseless failure at the same time of AI and hype could lead to confusion about a clear understanding of the AI field. In some cases, misunderstanding about AI led to hype, disillusion, firing, and real criticism, even among many seniors experts of the AI domain. So we detected the need for a short AI approach for everybody with shallow technical aspects and let the very hard aspect to we AI specialists only. And so a very short, comprehensive overview of a wide and very vast AI field should be necessary for providing fast insights for a better contextual understanding, putting all aspects together in few pages, based, of course, on empirical studies. And we did that as our modest contribution to scientific AI literature. Part 1, introduction. In the introduction, we recall that the birth of artificial intelligence itself happened during a 2-month workshop at Dartmouth College in the summer of 1956, organized by an influential figure in AI, John McCarthy, assembling 10 carefully selected proponents of automata theory scientists. They defined there, during the workshop, artificial intelligence as a new specific field that embraces the idea of duplicating human faculties, such as creativity, self-improvement, and language use. AI is the only one that is clearly a branch of computer science, and that attempts to build machines that will function autonomously in complex and changing environments. Also announced in the introduction, the foundation of artificial intelligence that are associated to have a goal of creation of intelligence for machines. We discuss the path to our future goals of humanity in the creation of intelligence for machines. And finally, as the development of the AI technology, unfortunately, also implies tremendous risks for the future of life here on the Earth, we propose exciting worldwide, specific, and global solutions to the management of ethics and risk of AI. Part 2, depicting artificial intelligence. Here, via our own illustration that we proposed for the first time 2 years ago in the case study of the 4th book reports of our PhD program, we depicted the whole AI field for a fast overview. How? We gave a picture of artificial intelligence definitions. We gave also a picture of implication of data in machine learning. I did a picture of implication of the 4 foundation of machine learning techniques to our AI. And finally, the whole picture shows that the crafty combination of machine learning techniques that makes machine or system behave, think, and act like humans is artificial intelligence. Part 3, the 4 pillars of machine learning. As illustrated in figure 1, previous figure 1, we've defined supervised learning, unsupervised learning, reinforcement learning, and deep learning as the 4 pillars of machine learnings. And as Professor Ari Sarden said, ML is the dominant mode of AI today. So we provide a clear overview of each pillar of ML. We first presented supervised learning techniques as a pattern recognition model with 3 possible outputs: conditional probability distribution, a classification, or a regression, with detail in the paper. Second, we describe unsupervised learning technique that naturally consists in learning with unlabeled examples using clusters. Subfields, self-supervised learning, and semi-supervised learning. The third pillar, reinforcement learning, as a behavior learning method based on either mathematical model, in this case it is called model free, or a word model, in this case it is called model based, with 2 approaches for each of them: passive reinforcement learning or active reinforcement learning. And from the 4th pillar of machine learning, deep learning technique that consists in learning with inductive connections or brain-like layered models. And from the fact that AI scientists are focused on creating a brain language that the DL technique, we had been led to make an original comparison between the biological neural network and the artificial neural network in figure 2 and table 1. So here in the table 1, we proposed this table for the first time in 2018 in the case study of the 1st book report of our PhD program. And we can see that, looking at the comparison, that the number, for example, the number of active connection between 2 neurons is at least 3 out to 8 for the biological neural network, while we have only 1 unique connection, binary link, between 2 nodes of an artificial neural network. So looking at the internal links and communication, we can clearly say that the artificial brain language and the biological brain own language are different in the details, the first trying to mimic the second. And we highlight that the nature of the biological human brain imposes a known and unexplored dimension of data that the artificial one ignores. Part 4, how the 4 pillars of machine learning techniques led to the current stage of AI. 4.1, the process of creating intelligence with machine learning. Here we start by showing, via this picture, that the Alan Turing Institute's machine learning framework effectively contains items of the 4 pillars of ML, with remark, neural networks, and other packages. And here we just show that from the 4 foundations of machine learning techniques, we could create intelligence via 2 methods, inductive learning or deductive learnings. So 4.2, the theories of intelligence. Talking about creating intelligence with machine learning models, let us elaborate about the nature of intelligence because psychologists define many types of intelligence. And as said, Professor Ari Surden, we can get intelligent automated results without intelligence at all. So it should be interesting to know type of intelligence we are creating each time. And there is these 2 basic types of model of intelligence in psychology: hierarchical models of intelligence, such as the 2-factor theory of intelligence or the Gottfriedson model of intelligence. We also have the multiple aptitude models of intelligence, such as social intelligence, kinesthetic intelligence, emotional intelligence, and creativity. 4.3, the path toward artificial intelligence. Here, based on 3 criteria, we provide in the following table, table 2, our classification of all machine learning categories implied in the creation of AI as AI path. So this table is based on carefully selected empirical research works proving the 10 categories. And it is possible, it's still possible to reinvent new and combination with the same intention of creating more capable, more intelligent AI agents, including expert system. Part 5, the path towards superintelligence or real machine intelligence. The ultimate goal of machine intelligence creation is not the current state of AI. The final goal objective is creating conscious and safe machines that can serve humanity's ambitions for a better world. 5.1, Foundation of Artificial Intelligence, we present findings and tools of 8 disciplines that are used to greatly distribute to ideas, viewpoints, and techniques of AI. These disciplines are the philosophy discipline, mathematics, economics, neuroscience disciplines, the scientific psychology disciplines, the computer engineering disciplines that provides tools via ML and AI packages for AI software development, the control theory discipline, the linguistic disciplines that provide tools for giving language ability to machines. 5.2, Views and concept of artificial intelligence. We provided here necessary elements of definition and utility for a clear understanding of the AI field. We detail in the paper, such as weak AI, that is simulation of intelligence, strong AI, true machine intelligence, the narrow AI, that is the mastering of humans' domain-specific knowledge or expertise by machines. Narrow AI is a multiple aptitude model of intelligence, as we mentioned in section 4.2, what intelligence are we creating? Also, artificial general intelligence is a human level of AI that is a hierarchical model of intelligence. Continue to define elements, necessary definitions such as black box AI, interpretable AI, explainable AI, and natural language processing. So we underline various definitions of machine intelligence, and looking at the final goal, superintelligence, ultra-intelligence machine, and singularity are the same state of conscious machines. Also, underline definition for ethics of artificial intelligence and risk of artificial intelligence. 5.3, the Turing test in the middle. Here, we present the Turing test with details that is necessary for checking if a created AI model has truly reached machine intelligence. And so far, no AI system worldwide has been able to pass the Turing test. 5.4, current path towards superintelligence or real machine intelligence. Nowadays, AI researchers master the narrow AI technology, but one AI model cannot yet aggregate several narrow AI skills and automatically switch from game playing to car driving or surgery as a human surgeon is able to do. So the research toward AGI is still ongoing, and the three pioneers and godfathers of AI won the Turing Awards in 2019 for outstanding contributions. I mean, Professors Jan LeCun, Professor Geoffrey Hinton, and Professor Joshua Benjou proposed different paths made of deep learning variants and that are promising to possibly surely lead to AGI. This award is about significant solutions toward solving the Turing test. We have also other approaches toward AGI. The OpenAI reinforcement-based software platform, that is an hierarchical model of intelligence. The OpenCog open source framework for developing AI systems that combine both multiple aptitudes and hierarchical model of intelligence, as we mentioned in session 4.2. Also have other initiatives that combine hierarchical representation and probabilistic language that produce hierarchical model of intelligence. And also have the robust artificial intelligence concept of Professor Gary Marcus. Anyway, the future of AI, starting by AGI, will surely emerge from one of the above current paths toward AGI. And in case it is something totally new, it will be then classified as a new AI path. When we will reach that human level AI, it will be the long path toward ultra-intelligent machines, also called of conscious machines. Part 6, ethics and risk of artificial intelligence. 6.1, performance of AI systems. AI researchers determine that the performance of AI system is provided via three powers: hardware, software, and data. Consequently, in artificial intelligence, ethical concerns can emerge from these three main aspects: hardware, software, and data. So in 6.2, we'll deal with ethical concern due to data. And we start that by human biases, 6.2.1. And here we show and understand that from our senses and perceptions, humans' biases could flow some way our judgments and lead to biases in the data collection process. So in the next session, we deal with biases in data. And here we show that biases in data, such as fallacies in language resource or corpora, and fallacies in word representation could lead to various stereotypes based on age, gender, racism, sexism, religion, ideological, political, moral, ethnicity, disability, sexual orientation, user features, and location in AI models. And researchers propose many solutions for detecting and measuring biases in data, and then devising techniques for overcoming them. However, in addition to these debasing techniques, better and sustainable initiatives for debasing data are those which deal with the data accurateness, not only at the collection phase, but also during the AI application deployment process with feedback improvement schemes. And this viewpoint is also supported by Professor Andrew Ng, who said that the focus has to shift from big data to good data, and having 50 thoroughly engineered examples can be sufficient to explain the learn. And we think data engineers have enough contribution to bring there. 6.3, ethical concerns due to software and hardware. Here we show that there is a clear evidence of risk in the development of the AI technology, but dealing with them, we should consider software and hardware together because there is a close dependency in their action, like with the mind-body theory we talked about in the beginning. And this is why we'll deal with software and hardware in the next section. 6.3.2, mitigating biases in AI. Software and hardware mutually and positively contributes to invention of new generation of AI technology in a fully integrated way. The best example is hardware-aware DL models. But fortunately, some vulnerabilities could emerge at software and hardware levels, no matter the data setting, leading to ethical concerns. Luckily, there exist various debasing methods for AI models that act at different levels of counterfactual data augmentation during the pre-training with context ED and dropout, and 3, after deployment, post-tuning debasing with word ED. 6.3.3, explainable AI and interpretable AI as solution to ethics and risk of AI. Here we show that explainable AI and interpretable AI concept aim to provide transparent AI solution for every given real-world problem. And so they are now guiding practitioners in the development of their applications. 6.3.4, green AI initiatives. AI models training process consumes tremendous quantity of energy while releasing huge amount of dioxide of carbon, TCO2, in the air, increasing worldwide energy consumption and carbon footprint. For example, we have the training process of OpenAI's GPT-3 that emitted up to 552 tons of dioxide of carbon provided by themselves against 59 tons for the Google's switch transformer. Enters the green AI concept that combats climate change and environmental risk. Green AI is part of a broader, long-standing interest in environmentally friendly and inclusive scientific AI research. And likely, red AI refers to AI research that focuses only on accuracy of performance for the energy consumption. Therefore, worldwide AI researchers are called to adopt a green AI strategy. 6.4, solution to ethics and risk of AI. Here, we provide worldwide global solution to the management of ethics and risk of AI. These initiatives tend to tackle the problem at its source, covering problems like AI regulation, AI safety, AI development guidelines, etc., no matter the specific framework and AI techniques. And the first global solution is the open letter from AI and robotics researchers from the Future of Life Institute, FLI, that imply thousands of AI scientists worldwide committing to not involve in development of lethal weapons. They also define Asiloma AI principles for the creation of a beneficial intelligence that helps in avoiding the risk of AI. A second worldwide global solution is the Future of Humanity Institute, FHI, a multidisciplinary research institute at the University of Oxford that brings the tools of mathematics, philosophy, and social science to bear on big pictures questions about humanity and its aspects. The FHI is led by one of the most influential figures in AI, Professor Nick Bostrom. Another global solution is the Montreal Declaration for Responsible Development of Artificial Intelligence, an initiative of Université de Montréal. The third principle of this declaration for responsible AI is the protection of privacy and intimacy that has become a subfield of AI research from the foundation disciplines of AI. Next, we also have the Institute of Ethical AI and Machine Learning as a global solution. It proposes 4-phase strategy toward responsible development of AI. Also, we have the Alan Turing Institute that proposes global solution for safe development of AI technology. Another global solution is a Seclear platform that de-risks the adoption of advanced AI algorithms for organizations by providing AI regulation, explainable AI, responsible AI, AI risk management, and monitoring. Being exhaustive, a last and global initiative ethics and risk of AI is the Booz Allen Hamilton AI for civilian services, in AI that allows governments to develop ethical AI that remain human-centered via the civilian and protects individual privacy rights and consistent with the nation's laws and values. This is a way to ensure AI-driven safe public life by the public sector. Of course, an interest for human-centered AI is that although AI could perform better than humans in several domains, we humans are the best at being humans, and we should make AI serve humans' welfare. As we can see in this paper, a comprehensive overview of artificial intelligence, the field of AI is very vast, and the similarity between many aspects of AI will lead to mistakes and or confusions for newbies and even so for some practitioners. Our paper proposes an approach that mitigates this struggle by covering worldwide milestones for the development of the artificial intelligence technology in a very short and comprehensive way. Even if this comprehensive overview cannot suddenly make of a reader an expert of the AI field due to possible limitations in novelty and technical aspects, it can bring a very good comprehension and invaluable insight. We presented artificial intelligence with all elements of definition and utility so that there is a good knowledge of AI. We hope our results will shed light to anyone with interest in the field of AI, including newbies, some practitioners, developers, teachers of various disciplines, for a fast and clear overview about AI, students, decision makers, etc. Future research will focus on the correlation between AI and all other disciplines, on profiling the way they use AI in their activities, and so proving correctly the global implication of AI in all fields of activity. And we say all contributive suggestions are welcome. Acknowledgement. We like to thank first our supervisor, Professor William Martin, and also Professor Abdo Miled, our second reviewer, and the whole BIU staff for the reviews of the reports of our PhD program, and for the access to a partial scholarship leading to this highest level of specialization in artificial intelligence. Valuable things we learned there are the support for writing this paper. We are also thankful to the Ivorian Civil Service, as we got access to this PhD program in 2018 as a computer scientist civilian from Côte d'Ivoire. Local initiative encourage commitment to training and to a field of research for civilians. Thank you.